Hi, everybody. My name is Brian, and I wanted to present my course project for the ML Fundamentals for Product Managers course offered by Duke University on Coursera. Beginning with the problem statement, we were given the task of training an ML model to predict the electrical energy output, or PE, of a combined cycle power plant. The goal was to select the most appropriate model that would have the best performance in predicting this PE value given other environmental sensor inputs. We were given a data set in the form of a CSV file with over 9,500 observations from environmental sensors. This data set included the temperature, ambient pressure, relative humidity, exhaust vacuum, and the net hourly electrical energy output, which was our target. The first step was to determine what is the most appropriate modeling task to use for building and training this model. Because this was numerical data and we had a goal of predicting a numerical target, I felt that linear regression was the right choice over classification. I wanted to design models by selecting different combinations of the four features that were provided in the data set. But going in, I also wanted to figure out what is the potential for outliers having an impact on the model's performance. So I started with a hypothesis. I hypothesized that the mean squared error, or MSE, and the coefficient of determination, or R squared, would be the most appropriate output metrics to evaluate the different models. There was a relatively small data set and hopefully a small chance of outliers. But just to make sure, I also wanted to train models optimized for the mean absolute error, or MAE, which tends to handle outliers a little bit better, and see what the performance was like in both of those cases. To solve this problem, I turned to Google's Vertex AI platform, where Google AutoML now lives. This platform is really powerful. It provides the ability to randomize and split your data automatically into training, validation, and test sets. However, a couple caveats. AutoML tables already pre-selects an algorithm, and unless you go to a custom pipeline, you can't really easily change and tune the hyperparameters. So these are some caveats going in. In order to select and build and train the models, I started with two models, A and B, that would optimize for the root mean squared error in model A and the mean absolute error in model B, but use all four of the features that were in our data set. When I began training model A, it became very obvious that the AP and RH features were significantly less important based on what Google was telling me. And so I also wanted to train models, C and D, that would contain only the top two most significant features, AT and V. And so those became models C and D. So let's see what Google Vertex AI told us. You can see in this table that we've got the R squared values, the MAE values, the mean absolute percentage error, as well as the root mean squared error. And what was really interesting is that the R squared coefficient for model A was the highest, and the other output metrics were the lowest compared to the other models. So given these results, I decided to go with model A. The output metrics I was getting back from Vertex supported my hypothesis that optimizing for the MSE and R squared was the right approach. And even though the two models, C and D, that had fewer features, didn't result in higher R squared values. But I also wanted to test Model A in practice. So I then took Model A and deployed it to a Google Cloud Platform endpoint. It gave me a simple UI where I was able to go back to the CSV dataset, put in the four different values for the features, and get a prediction from the model. And what I found is captured in the table on the left side. I found that the predicted values from this model were very close to the true values that were observed in the data set. In fact, it was over 99% accuracy. So given this, I feel that Model A seems to achieve a very high level of accuracy in predicting the values of PE. However, it's still possible that there's some overfitting happening here. So we could do further work to tune the hyperparameters and potentially look at using three features instead. And while this was a great opportunity to get some hands-on learning, I do feel that Vertex AI did a lot of the heavy lifting. So it will be interesting to compare these results with your results, potentially even using Python data science libraries and selecting different algorithms. So with that, I wanted to say thank you for your time and take care.